Let us now go through some practice questions on binary operations. So we're going to deal with pretty much everything here and even more practice questions. So remember to subscribe to the channel so that when I upload more videos on binary operations and even other topics, you access them very fast. So we have a question here. The operation star on a set of real numbers is given by this, where A and B are members of the real numbers. Is the operation binary on R? So when questions come like this, so let me just give you first an example so that you understand there. So if they tell us that let's say A star B is equal to A plus B, or let me just say A minus B. So this is our operation, and then they tell us that it is operating on natural numbers. So here you know that natural numbers, they are numbers which start from 1, 2, 3 going all the way up. So and then the question is this operation binary? Is this operation binary on natural numbers? So for you to determine whether it's binary, you have to think, okay, so my operation is A minus B. Okay, good. So since my operation is A minus B, this means that when I put in a natural number here, let's say for example I put a natural number such as 7, I also put another natural number, maybe 2, the answer should still remain a natural number. Remember in the previous video we talked about the closure property, the closure rules. So ensure to check out that video if you didn't watch it. So according to the closure rule, this is a natural number and this is also a natural number. When we operate on these two, the final answer we get should also be a natural number. So 5 is a natural number. Okay, good. So you can think of any other natural number. Okay, another natural number, let me say 20 minus any other natural number, let me say 8. So 20 and 8 are natural numbers. If I operate on them, I get 12, which is also a natural number. So this is showing that the operation is true for natural numbers. It is binary. But we have to think of an impossibility whereby it's going to lead to something not natural. So we can think again, okay, another natural number, let me get 3 minus any other natural number, let me get 7. Is the answer I'm going to get a natural number? You will get negative 4. And negative 4 is not a natural number because natural numbers start from 1 going all the way up. So in this case, you are going to conclude that therefore the operation star is not binary on natural numbers, because when you add a certain combination, you are going to get an integer. So this negative is an integer. So this is how you answer such questions. So now coming to the one we have now, the question is the operation a binary on real numbers? So you have to think of two real numbers whereby, so I have 2a minus 3b, this is squared minus 5b squared. So now what you have to do is you have to think what two numbers, if you put where there's a, you put that number, and then the other number you put it where there's b, you are going to get two real numbers, and then you should end up with a final answer which is not a real number. So For real numbers, usually we usually just get to conclude yes, it's binary, except when we have a root. When we have a root, then we can think of ways in which we are going to ensure that in here we end up with a negative so that it becomes a complex number. So remember the sets of numbers we have. Where do we start from? We have whole numbers, natural numbers, integers, real numbers, complex. Yeah, those things. So in such a case, you can think of any number which is a real number. You can think of maybe a fraction. You put 2 over 3, it is a real number. You also put here maybe 1 over 5, which is a real number. When you work it out, you are still going to end up with a real number, whatever you do. So for the first one, you just say yes, the operation is binary on real numbers, unless if you can manage to think of two real numbers whereby if you put them here and there, you should get a complex number. Yeah, if you can think of something, you just conclude. I don't want to stress myself. I'm not a student of natural sciences. So let's go to question 2. So question 1, yes, it is an operation. So usually they give to determine whether it is true on natural numbers and also integers. In the previous video, we even looked at a question involving integers. So number 2, determine whether the operation is commutative. So commutative, remember, we say A star B should be equal to B star A. So we're going to work it out. So this is called the left hand side and this is called the right hand side. So we're going to deal with the left hand side. The final answer, we compare it to the right hand side and check if we're going to end up with the same thing. So starting with the left hand side, we have A star B, it's equal to 2A minus 3B squared minus 5B squared. So we can simplify what's in the brackets. So remember, when you have 2A minus 3B, when we have a square, it means you multiply by itself. Yeah, so you multiply 2 by 2A, again 2 by 3B. Again, you multiply 3B times 2A, and then 3B again times 3B. That's what the power means. So you can do that on your own. I also showed you a shortcut in the short video which is labeled Math Mega Tips. Yeah, so in that short video I showed you how to quickly do this, and that's the method I'll use. So to expand here, we just say what is 2A times 2A? It is 4A squared minus what is 2A times negative 3B? It is 6AB. And then since it is to the power 2, meaning we do times 2 here. So remember, just say 2A times 3B, whatever we get times 2. So I've gotten 6AB times 2, it is 12AB. And then plus negative 3B squared, we're going to have 9B squared here. 9B squared. And then don't forget, we also have a 5B outside. So here we just simplify. We are going to have 4A squared minus 12a. So remember, you can also use that other long method. You still get this up to here. Minus 12ab plus, so 9 minus 5, that is 4. Okay, so this is our left hand side. So this is our left hand side. We cannot simplify further here, there are no like terms. So we go to the right hand side. So for the right hand side, we have b star a. So b star a, meaning always the thing. So meaning here we start with b. Instead of writing 2a, we're starting with 2b. By now you understand. So we write 2b minus a is now the last thing, squared minus 5a squared. So remember, we've just swapped. While there was a, we now put b. While there was b, we put a. So for the commutative law, we said we just try to check if we change the positions. While there's a, we put b. While there's b, we put a. Are we going to get the same thing? So I've seen what we've gotten on the left hand side. So now let us test on the right hand side. So when you simplify this, you just say 2b times 2b, it is 4b squared, minus 2b times negative 3b, that is 2b times negative 3a, that's negative 6ab. 2 times 3, 6. A times b, b. And then since we are raising to the power 2, we multiply whatever we get by 2. So we end up with 12ab squared. Oh, just 12ab. And then we square, so negative 3a times negative 3a is positive 9a squared. So remember, you are at liberty of doing this. You just open the brackets one by one. If you feel this will confuse you, now you open one by one and then you start multiplying. So from here now, don't forget we also have minus 5a squared outside. So at this point we just simplify. So I have 4b squared minus 12ab plus, so this is 9a minus 5a, which is 4a squared. Yeah, so here we can basically just rearrange. So let me just rub this. Yeah, so and then let me just move this a little bit high. So here we are going to say we can rearrange. We are rearranging in alphabetical order. So the thing that has a, so we write it. We have 4a squared minus, we can write 12ab, and then we write 4b at the far end. So 4b squared. So we've just rearranged without changing anything. So you can see what we have on the right hand side is equal to what we have on the left hand side. So you even conclude to say, therefore the operation is commutative. Remember, commutativity is when the left hand side is equal to the right hand side, and you can see here. So ensure you write your conclusion. You say therefore since the left hand side is equal to the right hand side, then the operation star is commutative. Yeah, so now we can proceed. Okay, so the next question, question 2. I always say I hate associative. So it's going to have a lot of things. So remember, the associative law states that A star B star C. So it's just like the commutative law. The commutative law looks at two things when you change the position of two things. But for the associative, it deals with 3 elements. Yeah, if we change how we start, are we going to end up with the same thing? So here, we're going to, so this is our left hand side. So this is the left hand side, this is the right hand side. So are we going to get the same? So we can start. So remember, A star B is equal to 2A minus 3B. So this is squared minus 5B squared. So we want to do, why did I even write this? Although we'll come back to it. Yeah, so we want to work out A star B star C. So beginning with A and B first only, just A and B. So what is A star B? So meaning where there is A, we put A. Where there is B, we put B. So this will be 2A minus 3B squared minus 5B squared. And then from here, we're going to say, oh, so what we have done, we've just done A star B, meaning that after we're done with A star B, we're going to do star C. So star C is just following, it's waiting for its chance to join in the calculations. So we can simplify this part. We're going to have, so remember here we are having 12A squared or 4A squared 12AB minus B 4B squared. So when we expand this, we're going to get that. And then we have plus 5B squared. So C is just waiting for his chance, star C. So before we can involve C, we have to check, is everything here simplified? So we have like terms here, 4B squared and 5B squared. So meaning we can simplify this. So negative 4 plus 5, that is just positive 1. So when we simplify this part, we remain with B squared. So star C. So since we've simplified this part was for A star B. Since we've simplified it, then we can now consider C. So always remember the first part. So like in this case, the first part it's A, and then the second part it's our B. So meaning in this operation, where there's A, we're going to put the whole lot of this, and then where there's C or where there's B, we'll put C. So we can proceed. So the best way to learn this, you can just try, maybe you're just following how things are coming, and then you resolve again on your own. Solve. So what is our operation? Our operation, they said A star B, it is I've forgotten. A star B, it is 2A minus 3B. Okay. So our operation is 2A. So our operation is 2A minus 3B. This is a square, and then outside we're having, I think, 5B squared. So this is the general operation which we have been given. Yeah. So from here we'll say, remember this side is the first thing. So this was supposed to be A. So this is the general operation, 2A minus 3B. So remember, the first thing is A, and then the second thing gets to be it's B. So wherever there's B, we put C, and then wherever there's A, we put the whole lot of that expression. So we have 2, and then where there's A, we put this, which is 4A squared minus 12A plus B squared. So this doesn't look nice. So 12A AB plus B squared. The whole lot of this, that is A, which is there, minus 3, and then where there's B, we're putting C. You see that, which is here. And then don't forget we have a square. We have a square outside. Minus, we also have a 5B here. So this is a lot of work. No wonder I said I hate associative law. So at this point, before we even proceed here, we can simplify this part. Yeah, you can see we have 4, 12, and 4. We can quickly just divide by 3. Yeah, so let us divide by 3 so that we make our work easier. So let us divide by 4. We divide throughout by 4. Yeah, so when you do the same throughout, then you haven't changed the meaning. So we're just simplifying this part. So meaning 4 divided by 4, it is 1. 4 divided by 4 here. 12 divided by 4, it is 3 here, and then here it is just 1, as if I knew, though it was a mistake initially. I was supposed to write 4A. So we've just simplified this part so that at least when solving, it's not so complicated. Yeah, so we proceed. My keyboard is the lesson has ended. Seems like power has gone here. Yeah, okay, so see you in the next lesson. It's back. So we proceed. Here we just want to multiply and see what we get. So what is 2 times A? It is 2A squared minus 2 times 3, 6AB plus 2 times B, 2B squared, okay, minus 3 times C, 3C. So this is what we get. So here we've opened the brackets for this one. 2 times A, these are the things, and then 3C, 3 times C, it is C, and then don't forget to have a power 2 outside, and then minus 5B. So from here we just there's nothing that can be simplified, so we open the power 2. This will be 2A squared minus This question goes for eternity, unfortunately. 2a squared minus 6ab plus, where is this b coming from? Oh, when we multiplied by 2. Okay, so 2b squared minus 3c. So we multiply by itself. 2a minus 6ab plus 2b squared minus 3c. Yeah, so we've just multiplied this by itself, that is the power, and then don't forget to have 5b at the far end. So from here we now have the work of multiplying one by one. I'm a very lazy mathematician. I hate such. So what is 2a times 2a? This is work. So 2a times, so this is a squared. 2a squared times 2a squared. This is 4a power 4. A squared times a squared, a power 4. And then, so this 2a is multiplying everything here. So 2a squared has multiplied this, minus 2a squared times 6, it is 12. And then a becomes power 3, and we have a b there. A squared times this a cubed, and the b here. And then we come to this one, 2 times 2, 4. A squared times b squared, it is just a squared and b squared, minus 2 times 3, it is 6, and then a squared times c there. So we've just multiplied, we've multiplied 2a with everything in here, and we're not done. We have to multiply again negative 6, which with each one of these. So we continue, minus, I feel like stopping, negative 6ab times 2, it is 12. So here we have ab times a squared, meaning we have a cubed, and then also a b there. So let me just highlight what we're multiplying so that you don't get lost. So we're now multiplying negative 6ab with everything in here. Yeah. So we've multiplied this, we've multiplied, we have now come here. So what is negative 6 times negative 6? It's positive 36. And then ab times ab, it is a squared and b squared. And then from here we say this negative 6 times this one here. So 6 times 2, that's 12. And then ab times b squared, it is a b cubed. We have b power 2, meaning with this it becomes power 3. And then the last one there we have what? The last one we have 6ab times negative 3 there. So this becomes positive 18 ABC. Yeah, so you can see the work which is here. This again, it will multiply everything. This again, it will multiply everything. Yeah, so in the other videos we'll look for a very short way of expressing it. Yeah, so that's basically how you do the associative law. So here where were we? So when you write everything and then you just put them in order, you write them in alphabetical order. And then now when you do the right hand side, after simplifying everything, you have to ensure that everything is exactly the same. 4a, it's having power 4. If you have a negative 12, it's having a power 3. They should be just the same. Although you can have something like this, b and a power 3. You just have to rearrange. Multiplication, you just rearrange, no problem. Yeah. So, if it happens that something is missing, like they are not the same, you just conclude that therefore it's not commutative. I think I won't go all that far. We can look at these other interesting questions. So the next one, a very simple one. We have evaluate 3 star 2 star 5. So what do we get? So remember we said a star b, this is what was given. A star b, it is 2a minus 3b squared minus 5b squared. So now we want to find 3 star 2 star 5. So what we start with, we just start with 3 star 2. So meaning while there's a, we're putting the first number, which is 3. While there's b, we'll put 2. Meaning we're doing 3 star 2. So we go a, while there's 2, while there's a, we put 3. While there's b, we're putting 2. So this is squared minus 5. While there's b, we're putting 2. 2 like this, and 2 is a square. So we just simplify, and then what we're just dealing with 3 star 2, meaning star 5 is just following. So here we have 6. 2 times 3 is 6. 2 times 3, this is 6. And then minus 3 times 2, this is also 6. The solution doesn't look okay, but we go with what we have. Are we making a mistake? So this is 5, and then 2 squared, that's 4. So here we have 0 power 2 minus 20. So meaning we have a negative 20 on 3 star 2. And then don't forget star 5 was just waiting for us to simplify. Okay, so we proceed. So now we are now going to do negative 20 star negative 5. So we work on that. So here, what is let us first remember our function. So the function, or the operation rather, the operation is 2. It was 2a minus 3b squared minus 5b squared. So now at this point, the first item is 20, meaning it gets a. The second item is just positive 5. So 5 is b. So wherever there's a, we put 20. So this is 2. While there's a, we're putting negative 20. Minus 3. While there's b, we put 5. Minus 5. While there's b, we put 5. Yeah. So from here we'll now say this is negative 40 minus this is 15 squared. So 5 times 5 is 25, and then what do you get when you say 25 times 5 should be 125. So here we have 125, and then in here we subtract what is 40, negative 40 minus 15. So it's just like adding them. So it is negative 55 minus 125. So I don't like the solution. So just ensure you resolve it again, solve, and then ensure you don't make any mistake. So what is negative 55 minus 125? We're getting 180. So this is how you can go about it. So just know the steps and do it carefully. Yeah, and then always remember, practice makes perfect. So the more you practice, the more you get better. You even be able to know that at this point I make a lot of mistakes. So let me slow down when I reach here. You learn all that about yourself when you practice more. So and then the next question is find the values of k for which negative 2 star k is equal to 80. So they're telling us that negative 2 star k is 80. Okay, so firstly let us do negative 2 star k. So always remember what is the original function. The original function is negative the original function is 2a minus 3b squared minus 5b squared. So where there is a, so meaning this is our a, this is our b. Where there is a, we put 2. Where there is b, we put k. Yeah, so by now you have gotten the pattern. So we go 2. Where there is a, we put negative 2. So this is minus 3. Where there is b, we are putting k. And then we square minus 5. Where there is b, we put k. So they have told us that all this is equal to 80 when you say negative 2 star k. So at this point we proceed. We say negative 2 times 2, this is negative 4 minus 3k. We have a square outside, and then outside again we have 5k. This is equal to 80. So we just simplify this part. So negative 4 times negative 4. So remember, you just open the brackets. You open them like that, and then you multiply one by one. That's the normal way. Or me, I use this shortcut, which should give you the same answer. Negative 4 times negative 4, that's 16. And then negative 4 times negative 3, that is positive 12k. Since we have a power 2, we multiply this by 2. So this becomes 24. And then plus 3k squared, meaning 3k times 3k, it is 9k squared. So here meaning we have opened the brackets at this point, and then we have a minus 5k. All this is equal to 80. So rearranging and simplifying, we'll get 9k squared plus what is 24 minus 5. We're going to get oh wait, so here, so remember to always counter check your work. So this is negative 5k. It was supposed to have a square, so remember minus 5b, it's having a square outside, so this is squared, so the k is squared. Yeah, so meaning we can write the like terms. So 9k squared minus 5k squared, and then plus 24k, and then 80 can cross, it comes to the other side, minus 8. So this is equal to 0. And then we still left some business here. And then we just go on simplifying. So remember, you don't say equal to when you have an equal sign already. So from here we just say so from here we just simplify 9 minus 5, that is 4. So 4k squared plus 24k minus 80, this is equal to 0. So at this point you can divide throughout by 4 to just simplify. You divide throughout by 4. 80, is it divisible by 4? Yeah, so surprisingly yes. So divide everything by 4. So this is not undefined. So k squared plus 24 divided by 4 should be 6, minus here 80 divided by 4, is it 20? These silly mistakes. So these are some of the things which can be quite costly. Yeah, so remember we have 16 here, but I forgot to write it. Plus 16. Yeah, so even here, before this, I was supposed to say I have a positive 16. So positive 16, and then that's when we bring in negative 80. Yeah, so we forgot our negatives, our positive 16. So positive 16 minus 84, that is 64. Meaning this part, when we simplify, we're getting negative 64. Yeah, so now we've made the correction. So 64 divided by 4, we get 16. So this is our 16, this is just 0. And then from here you now quickly finish up. You can find the product, sum, factors. The products here, the product is negative 16, the sum is positive 6, the factors, what two numbers can you use? 8 and 2. And then to have a negative, we put 2 to be negative 2, meaning 8 times negative 2 is 16. And then the sum, 8 plus negative 2, it's positive 6. So this will be k squared, k squared, which one should I start with? Plus 8k minus 2k, and then minus 16. This is equal to 0. And then we try to factorize. Here the common thing which we have is only 8. Oh, it's only k. So k is factored out, we remain with 1k plus 8, and then on the other side what's common is -2. Here we remain with k, and then there plus 8. This is equal to 0. And then the common things, k minus 2 and k plus 8. Yeah, so the values of k, you quickly finish up. You say k is equal to 2 or k is equal to -8. So that's how you solve. So this is typical of an exam question. Exam questions will look just like this. So please ensure when you're done with the video, you give yourself a break and then you come back and solve it all over again. It will really help you. Repetition is the key to success. Yeah, so but ensure you repeat. So we've solved this, and then for each member x in real numbers. So this is the question. So for each element x which is a member of real numbers, determine if it exists x inverse in the real numbers with respect to the operation. So given this operation, does it have an inverse? That's the question. So instead of here, they are just supposed to say, does it have an inverse? Now, no, x is a member of real numbers. Determine if x inverse Shani with respect to Shani. Yeah, just to make you scared. So they're just asking, does the inverse exist? And then you just say yes, and then you're done. So, but remember, such answers are very silly in mathematics and also physics. When they ask you, you have to defend your answer. Why have you said no or yes? So to determine whether an inverse exists, we have to know whether an identity exists. So remember, even on the laws of binary operations, those rules, when we talked about the identity and the inverse, I even wrote them together on the same page because they are quite related. So starting with the identity, so we cannot talk about the inverse without the identity. So for us to talk about the inverse, we should have the identity first. So let's talk about the identity. Does this have an identity? So do we remember the property for an identity? We said for an identity, when you have A star E, meaning when you operate any number on an identity, you should just get the same answer. Yeah, so like we even gave an example. If you do 1 plus 0, it is just 1. 2 plus 0, it is just 2. Even negatives, -4 plus 0, it is just -4. You get the same number. So this is the identity for addition and subtraction. You just get the same thing. And then for multiplication, the identity is 1. If you say 2 times 1, it's just 2. -3 times 1 is just the same -3. So that's an identity. You operate an identity with any number, you get that same number. Yeah. So this means that we have A is equal to A star E. So for us to find the identity, we just have to do A star E, and then we make E the subject. Yeah, but here now we don't want to find the identity. So let's see where the question takes us. So does it have an identity? So we're going to say A star E is equal to So remember we have A, so we're saying A is equal to this A star E. So we can just write it here. A is equal to A star E. So what is A star E? Meaning the first letter is A, and then B, which is the second letter. Wherever there's B, we put E. So this will be 2A minus 3. Where there's B, we put E. Squared minus 5B. Oh, instead of writing B, we put 5E squared. So from here, we just say 2 times A, it is 2A minus 3E. This is squared minus 5E squared. And then here we open the brackets. So when you expand properly, you are going to get 4A squared minus 12AE plus 9E squared. And then here we have 5E squared. So here you just expand, you get this. So what is 9E minus 5E? We know it is 4. So meaning this is reduced to 4. So 4E squared. So what we have here, it's equal to A. So now for this identity, remember when we say A here should be equal to whatever we operate. Remember, if this is, let's say, 2, when we say 2 plus 0, we know the left and the right are same. Even if we add this identity 0, we'll still get 2. Yeah, so that is the basic. If we have 3, and then maybe it is multiplying 3 times 1, it is just 3. So this is the identity property. So now at this point where we have reached, you can see what we have on the left and on the right. So this expression is absolutely not the same. The left hand side is not equal to the right hand side. The right hand side. Yeah, so no matter what number we put here on A, let's say maybe we put 1 where there's A. If we put 1, still 1, here if we put 1, and then on the other side when we operate, we're not going to end up with 1. So it didn't lead to the same thing. So the identity does not exist. So since the identity does not exist, then even the inverse does not exist. Yeah, so the identity does not exist, you write. Therefore, even the inverse. So in this question, symbol for inverse, they just use this. So the inverse does not exist. So you even conclude. So they said determine if it exists. So if you want, you can even sound fancy, where you say therefore as determined by the solutions above, the inverse does not exist because the identity does not exist on the operation. Yeah. So I will end here. So don't forget to subscribe because we have more interesting questions which will be answered in some other videos. So you can just stay tuned. When the video is uploaded, you'll be notified. So we'll do questions like this. So we have something nice here. This is going to be work. Yeah, so such questions, so you can even screenshot this and then you even solve in advance you send me your solutions. Yeah, you send me your solutions, and then I can mark you even before you go through the video. Yeah, so you can try out this, and you can try out this one as well. Yeah, so all these, I think these two will be in one video. Yeah, we're going to look at them. So, but for now we end here. Remember to keep on revising, keep on practicing. Yeah, so we have answered at least something here. So now see you in the other lessons.